Regional aviation is vital, fueling social and economic development, as well as supporting and connecting the lives of millions of people around the world. However, current regional aircraft use technology from a generation ago, and there is room for significant improvements to cabin comfort and operational economy. Using world-renowned Japanese quality, design, and service, Mitsubishi Aircraft is committed to changing the status quo for regional aviation and transforming the regional travel experience. Mitsubishi Aircraft. The Mitsubishi SpaceJet is a revolutionary change in the regional aviation market, creating unprecedented standards for cabin comfort and aircraft performance. The Mitsubishi SpaceJet offers unparalleled cabin comfort and industry-leading operational economy, opening new doors and business potential for regional aviation. Japan has picked up Mitsubishi Heavy Industries as a main contractor to develop the country's own next-generation stealth fighter for launch in the 2030s. The next-generation fighters, currently known as FX, are part of Japan's upgrading of its aging fighter jet fleet as the country builds up its military capability to counter growing threats from China and North Korea. The next-generation stealth jet will replace F-2s that Japan co-developed with the US. They are due to be retired around 2035. Mitsubishi F-2. The F-2 support fighter aircraft is a multi-role single-engine fighter aircraft principally designed for Japan's Air Self-Defense Force, JSDF. It is the result of a joint Japan and USA development program. Mitsubishi Heavy Industries, MHI, is the prime contractor, and Lockheed Martin Aeronautics Company serves as the principal US subcontractor. The F-2A is the single-seat version, and the F-2B is the two-seat version. The Japanese Defense Agency originally planned to procure a total of 130 F-2 aircraft. Japan is currently developing a new advanced fighter jet to replace the Mitsubishi F-2 support fighter aircraft. The aircraft's integrated electronic warfare system, mission computer, and active phased array radar were developed by Mitsubishi Electric. An M61A1 Vulcan 20mm multi-barrel gun is installed in the wing root of the port wing. There are 13 hardpoints for carrying weapon systems and stores, 1 on the fuselage centerline, 1 on each wing tip, and 5 under each wing. The store's management system is supplied by Lockheed Martin. There are 2 Fraser-Nash common rail launchers manufactured by Nippey. The aircraft is capable of deploying the Raytheon AIM-7FM medium-range Sparrow air-to-air missile, the Raytheon AIM-9L short-range Sidewinder, and the Mitsubishi Heavy Industries AAM-3 short-range air-to-air missile. The F-2 is armed with the ASM-1 and the ASM-2 anti-ship missiles. Mitsubishi started developing the Type 80 series anti-ship missiles, ASM-1 and ASM-2, in 1980, originally for the F-1 fighter. The fighter aircraft can also carry 500-pound bombs, CBU-87B cluster bombs, and rocket launchers. The centerline and inner wing hardpoints can carry drop tanks with a 440,000 kilogram fuel capacity. Subaru Aerospace Company. The aerospace company, by leveraging tradition and innovative technologies, develops and produces a wide variety of aircraft and components for major customers such as Japan's Ministry of Defense, JMOD, and Boeing. As to the rotorcraft programs, Aerospace Company successfully completed the joint development with Bell Textron Inc., USA, of the commercial helicopter Subaru Bell 412 EPX, which is also utilized as the platform for the new utility helicopter, the new UH, for Japan's Ministry of Defense, JMod. Fuji T-7. Fuji T-7 is a primary military trainer aircraft manufactured by Fuji Heavy Industries, FHI, for the Japan Air Self-Defense Force, JASDF. The aircraft replaced the T-3 trainer that is in service with the JSDF. The Fuji T-7 is used for basic flight training by the Air Training Command and the Air Development and Test Command of the JASDF. The aircraft are currently operated by the 11th Flying Training Wing, the 13th Flying Training Wing, and Air Development and Test Wing. Fuji T-7 is a longer and heavier variant of the T-3 trainer. The aircraft incorporates a low-wing monoplane design, including a modified cowling and wing. It integrates a turboprop engine in place of the piston engine used in the T-3 trainer. The turboprop engine delivers high performance and reduces noise levels. The aircraft has an overall length of 8.59 meters, wingspan of 10.04 meters. The wing area of the Fuji T-7 is 16.5 square meters. The Fuji T-7 trainer aircraft has a maximum speed of 376 kilometers per hour. The cruise and stall speeds of the aircraft are 296 kilometers per hour. The aircraft can fly at a maximum altitude of 7,620 meters. Kawasaki. In World War II, Japan's heavy industries would end up going from round-the-clock production of war material to virtually complete destruction in only a few short years. But during Japan's brilliant MacArthur-era post-war reconstruction, Kawasaki's extensive experience in heavy industry, developed for the war effort, would later be put to use manufacturing an entire new generation of civilian and commercial machinery. Though Japan was completely prohibited from manufacturing aircraft from 1945 to 1952, in the 1950s, Kawasaki would end up being a leader in manufacturing other revolutionary types of aircraft. The helicopter. In 1922, Kawasaki completed its first airplane at its Hyogo works and conducted test flights in Sohara Village, currently Kakamingahara City, Gifu Prefecture. The Japanese Army admitted its excellence based on the test flights and adopted it for the first military plane, the type Otsu-1 surveillance plane. Kawasaki T-4. On November 1981, the Japanese conglomerate Kawasaki was chosen as the primary contractor to develop and produce a suitable trainer aircraft, which was originally named the KA-850, to target the requirements of Japan's MTX program. Having beaten out bids from competitors such as Mitsubishi and Fuji, the MTX program had been initiated to purchase an aircraft that will take over the old Lockheed T-33 and Fuji T-1 jet trainer that were in service with the JASDF. Moreover, there was also a need for a planned trainer aircraft to replace some of the syllabus that was being managed by the Mitsubishi T-2. The design had to showcase a range of transonic aerodynamic effects and attain a high level of maneuverability, a comparatively low operating cost, and better reliability levels. Smooth handling was also essential so that trainees could convert from the Fuji T-3 piston engine after requiring just 70 flying hours. Out of these modifications and advancements, developed the Kawasaki T-4, a clean-sheet, indigenously developed intermediate trainer aircraft. The Kawasaki T-4 has a well-made, damage-resistant airframe that is mainly composed of traditional aluminum alloys, although some portions are made of composite materials. The aircraft structure has enough strength to enable high-gravity maneuvers, being rated to carry out spontaneous dives of 7.33 Gs when being flown in a clean configuration. It is equipped with a thick-section transonic airfoil developed by Kawasaki and Japan's Technical Research and Development Institute, TRDI, to give excellent high angle of attack handling and better spin characteristics. An uncommon aerodynamic feature of the aircraft is the light leading edge root extension, LERX, forward of the leading edge along the fuselage that generates additional vortex lift and improves the aircraft's high G departure proneness, like the refrainment of wing drop and pitch up while in aerodynamic stalls. The avionics were made digital to decrease both its size and weight while increasing its reliability. Usually, these systems and components have been domestically produced, despite the fact that some technologies from numerous American industries were incorporated, such as the inertial guidance system that uses laser gyroscopes built by Honeywell, and the air date computer that uses transducers from Sperry. Most of the onboard systems are typical, except for the use of a licensed onboard oxygen generation system, OBOGS, that was considered an unusual choice for a trainer aircraft and had needed ample effort to suit it for use aboard the T-4. Japan continues to offer a lucrative market for imported aircraft, aircraft parts, and engines. US firms have an overwhelming presence in the market due to a long-standing relationship, some spanning over 60 years, with domestic manufacturers and trading firms. US firms are presented with opportunities in the market as these Japanese industries undertake international products, develop transport and patrol aircraft for defense, and develop small jets and small jet engines for civilian aviation. We hope you liked the video, and we want to know which was your favorite. And don't forget to give the video a thumbs up and hit that subscribe button and the bell icon down below if you want to make sure you never miss out on important new information like this.